I'm going to show you two more complicated stellar model. The first model is an improved population model. In this model, we are not going to give you a simple function parameter, and we give you whatever realistic data you have. Our focus is two strategies to help the human being to maintain a healthy balance between the human population and the natural resources. You can think of the natural resource as the food supply. So how we human beings make the wise decision, either control the population growth or decrease, even in the developed country. And how do we reuse, recycle the natural resource, regenerate the natural resource? And how do we reduce per capita consumption of the resource? We have all different questions could answer to help the ecological system. This kind of research we call it ecology, right? Ecological system. So the difference you're going to see is instead of giving you a constant or a variable, we give you any time series, just like a real time data. Those data could be like the unemployment rate, could be the rate of starvation people, and could be the change of population over time. There might not be a smooth curve, could be a curve like that, and not even a curve. As a time series could be probably like that. So let's look at this model. In the conceptual level, we look at two strategies. The first one is reduce the natural resource consumption per person. Of course, it's easy to say, it's hard to do it in the material world. Like driving a smaller car, driving less, carpool, whatever you can do. And also recycling the water, the material. And then we look at what are input parameters you're going to consider. Of course, the P0, original population, and this is a controversy, the birth control policy. Do we encourage more kids, immigrants, or like one-child policy in China? I don't know. It's a hard question. No solution, by the way. And then we monitor the death rate and the resource regenerate rate and how much we invest to the green industry. I heard now China take over United States, be the #1 in the green energy. Next, look at the impact of conservation on the resource consumption. And you might make some policy about the taxing. You tax for the big car, gas, and the big house. That may help people to reduce the resource consumption. And then you also look at all the policy, how much they were going to impact for the birth rate. For example, high unemployment rate always reduce population rate because people postpone the time to raise kids. Back to stellar. I want to summarize it. Stellar have 4 layers. The first layer is the use interface. And what I showed you is the use interface which is a dashboard. And those buttons are the input control, and how you're going to control the simulation, the data, and like those, you control the parameter if you want to do sensitivity analysis. And this switch maybe turn on and turn off one of the parameter. And this big one here is the output, is the natural resource. Of course, maybe only goes down, and the population maybe goes up. Something, the population is the blue line, and the resource is the red line. That's where you visualize your result. That's the interface. It's all about input and output. And here could be the conceptual model, but the most likely the mathematics model in graphic representation. Look at the big box. The big box is population is one variable, and the resource is another variable. They're both a function of time t. And the population change because people born, decrease, people die, natural, right? And the resource regenerating or generating, if you have found the new, and the consuming. That's the, like the water flow in, flow out. That's matter. That's not a matter. You talk about a population, money, or resource. It's always flow in and out. If you look at the last lesson, we talk about the philosophy of stellar, just like those pipe and the filter. And what else we need to know? Oh, you have two control variables, and the people decide to have baby, but the people cannot decide to die or not die, unfortunately. And people can decide about the conservation decision. Those are the decision point. You make some decision. And you look at the feedback system. You always look at the information from those resource per person to make those decisions. See, that's why the decision line go that way. And then this process control the birth rate. The birth rate will control the being born and the population model. Dying, the death rate goes to how many people died, but how many people die is also in fact the consumption rate, and also the per capita resource will determine the price. Maybe the price will determine the natural resource consumption. And then you may invest to the regenerating. So those are the factors. In the beginning, of course, how do you know those kind of things? We call it a converter. You know, that only have 4 essential model elements. One is, of course, those we call it stock. It's a variable in mathematics. Again, I just give you a brief review. And those pipes, we call it flow. And the real here, this is the switch, we call it control, basically. And the converter, those are information, like your eye, watch the water flowing, and you turn off the switch. That's where you have the information. And the last one, those lines, like this line, are the information flow. We call it a connector. So STATA is so simple. All you need is 4 elements. The stock and the flow that characterize the material flow, and then the convert and the connector which capture the information flow. As a feedback system, it's always the information information, control the material flow, and you make a decision. Okay, this is the conceptual level. I did not go to the detail. I don't need. Well, now you look at the mathematics model. The last layer, we talked about the interface, conceptual model. Instead, we call it a map. And then the mathematics model in icon. And then the last one, mathematics model in equation. Pretty simple. Look, the natural resource right now equal natural resource a moment ago times the change by regenerating minus the consumption times the T. So basically, I'm talking about what you have now equals what you had a moment ago plus the change. The change is the regenerated minus assumption times the T. Well, the same is true for population. Look, the population now equal to population a moment ago times the newborn minus the new death. That's it. And then you put all the numbers, the original resource, the initial population, and the interesting thing is they give you all this thing as a graph function. Well, it's a good project because Stellar is very general model. You don't have to put any mathematics equation yourself. You don't have to have all the continuous function. You can put any data table, like a time series. And then you can look at this example to see if we can do meaningful research by using the real-world population data that fit no pattern, no function, just a curve. And you scale it down to millions, thousands of tons to make your number small. Now here's the game. If you have two teams, each team make your own argument about what strategy is the best. And then can you use this Stellar model and to do the sensitivity analysis and then to debate to win your point. That's what I called about insight. It's not about a number, but you need to, from the number to get insight.